Hello, I'm Kamalakar Thakare. In this presentation, I'm going to present our research work for pedestrian attribute recognition. The title of the presentation is Let's Observe Them Over Time, an Improved Pedestrian Attribute Approach. Pedestrian attribute recognition, that is PAR, aims to identify various attributes present in a single pedestrian image. A few examples of attributes are a gender, age, clothing patterns, accessories like bag, mobile, umbrella, etc. An accurate PAR is used for person identification, query-based retrieval, and scene understanding. These are two different representations of pedestrian attribute. The first image shown pedestrian depicted in bounding boxes, and the bigger boxes are depicting few attributes like short hair, paper bag, blue bike, etc. On the right, two pedestrian images and their corresponding set of attributes are shown. These are existing datasets available for attribute studies. As you can see, RAP, that is richly annotated pedestrian, and PA100K dataset are the large-scale dataset, while other dataset comprises of adequate samples. After dataset, we here discuss the critical limitations of approaches. So the existing PAR approaches utilizes special features available in the input image. However, image-based dataset has few critical limitations. First, due to a restrictive camera angle, it hampers the spatial features. This limits leads to ambiguity during inference. Second, not all viewpoint represent the best features for attributes, and due to limited viewpoint, performance reduce is observed. As you can see, occlusion hurts the prediction and appearances of attributes. In these examples, due to these occlusions, it is difficult to predict about presence of shoes, hairstyle, and gender. To mitigate these challenges, the probable solution is to observe pedestrian over frame by frame, that is, observe them over time. The change in perspective changes the appearances of certain attributes. To observe them over time, we proposed a multi-perspective approach for PAR. This is shown in this figure. It has three stages. In stage 1, we accumulate three vectors: class activation energy, confidence score, and attribute prediction by baseline network. In second stage, we employ self-attention mechanism to learn the correlation between activation energy and confidence score generated by the baseline network. In last stage, we combine these relationship matrices and train the fully connected layer using two novel losses. This is the block diagram of proposed self-attention correlation module, in which energy vector and class activations are used to obtain the correlation matrix. This correlation matrix is finally used to train the fully connected layer. We conducted extensive experiment on PA100K and PETA dataset. Table 1 summarizes the performance of existing method and our method on PA100K dataset. Second table represents the same on PETA dataset. It can be observed that our method outperformed existing method on both datasets. Here table number 3 represent effect of number of images used during the training on 3 datasets. We have conducted this experiment on 4 different values of k. In table number 5, we present ablation study on the proposed method. these are the result visualization of the output generated by our model. In figure number 4, we shown prediction differences between 4 methods including ours. In figure number 5, we depict class activation output for handful of attributes. Here we conclude our proposed work. So the conclusion is as follows. So existing PER approaches rely solely on spatial information from a single perspective, limiting their reliability and generalizability. We introduce a multi-perspective approach on PER to overcome the challenges often posed by a poor image quality, occlusions, and limited training dataset. We also validate our proposed method by conducting extensive experiment on PIR dataset such as market, PETA dataset, PA 100 kit and tube dataset. And we observe that our method actually perform well on this dataset.